Liquid level detection. What is it and why does it matter? I'm Michael Vuk, and this is Automation Academy, where we look to answer your questions and demystify the world of lab automation. If you're currently manually pipetting and you're looking at making the jump into automated liquid handling, there's some stuff that you need to have on your radar in order to avoid getting caught off guard. Let's look at an example. If you're currently plating samples manually, and halfway through that process, you ran out of samples, are you gonna keep aspirating air and dispensing it as if it was the sample? Of course not. That's a stupid question to ask. A robot might do it though. See, we have eyes to detect things like liquid presence and liquid level. If a robot does not have some sort of sensor or technology to do that same thing, it will do things like pipette air instead of the liquid that you want it to. Full disclosure, this is a little bit of a moot point depending on which systems you're looking at. Most of those larger automated liquid handlers come with liquid level detection standard. However, you have to be careful when you're looking at these smaller, benchtop friendly, entry-level liquid handling systems, because some of those leave out liquid level detection. I'm not 100% sure why. Presumably it's a cost savings measure, but this is a truly critical piece of technology in any automated liquid handling application. Two reasons for that. The first we already talked about, failed runs. You run out of something midway through and you keep aspirating as if it was there. I don't think I need to spend a lot of time elaborating on why that's a bad thing. If I do, just shoot me a DM. The second reason is a little more nuanced, and it has to do with cross-contamination and sample waste. When you're manually pipetting, you're going to be looking and telling how far you should be putting that pipette tip into the liquid in order to aspirate properly and avoid overwetting the tip. In automated liquid handling, there's two ways of telling the system how deep to put the pipette tip. The first is above container bottom. You have the coordinates of the labware and you say, hey, I've got the bottom of my plate here, go 2 millimeters above that and aspirate. That works fine because it is a flat container. The problem is the liquid level is usually not consistent across every single well or every single tube that you're aspirating from. So if you're just going from a fixed height above container bottom, you're risking overwetting the outside of the tip by submerging way too deep. When that happens, when you pull the tip out, that extra liquid on the outside comes down and starts dripping. Best case scenario, it drips onto your instrument and you've contaminated your instrument and you have to clean it. Worst case scenario, you start dripping sample into other wells, other tubes, other reservoirs, and you've got massive cross-contamination across your entire experiment. And that is a problem for so many different reasons that should be self-evident. Liquid level detection solves that problem by, instead of going a set height above the container bottom, it goes a set height below the liquid level. So the pipette tip will come down until it senses liquid, and then it'll go, say, 2 millimeters below liquid level. So you're only getting the very tip of your tip in the liquid, and you're not getting that excess forming on the outside to drip. This also leads to reduced sample waste, because if you have a very precious sample and it ends up on the outside of your tip, that sample is not getting experimented on. It's not having an assay run against it. And that once again causes some problems. This is why liquid level detection is so important. Avoid fail runs and avoid contamination. Now, next week, we're going to talk about the two different types of liquid level detection there are, what their strengths are when you'd want to use them. But for now, this is what liquid level detection is and why it's important.